Events are signals, or rather, signals are events. Even Godot's documentation will tell you so. Before C# was introduced to Godot, GDScript already had the concept of signals, an easy to understand paradigm for notifying nodes of changes on other nodes. When C# was added, signals were implemented on top of the already existing C# event framework. This extra layer allowed Godot's developers to ensure that C# and GDScript could listen to and respond to each other's signals. The thing is, though, as great as cross-language scripting is, you shouldn't be doing that much of it. There is overhead, and so you should be sticking to C# or GDScript unless there's a really good reason not to. Also, native C# events have a host of benefits over signals. If you're using the system namespace, the syntax is a lot cleaner. You can set them up so that the event handlers can have return type, and you can also broadcast events from any class, whereas with signals, it has to be a class that inherits from a node type. Because of these reasons, myself and many others forego signals in favor of C# events when programming in Godot. So how can you do that too? Well, let me show you. Here in Godot, we have a simple scene called TimedGreeting. I'm going to play the scene real quick, just to see what it does. Oh, hello. Okay. So this scene prints a different greeting every 2 seconds. Awesome. Well, let's stop this and look at how we have things set up in Godot. In our scene tree, we have 3 nodes, a main control node, a centered label, and a timer. That's it. The main control node and the label node each have scripts attached. Let's take a look at the one that's attached to the TimedGreeting main control node. At a glance, you'll notice that most of the action happens here. First, you'll notice that we're declaring a custom signal called greeting, which takes a string parameter. Next, we have an array of strings that hold different greeting messages. Where there's an array, there's almost always an index variable, and we have ours here. We finish up the member fields with a reference to our timer node, which we load up using a call to getNode here in the _ready method. That's followed up by us listening for the timer's timeout signal. When that signal happens, the onTimer timeout signal method will be called. In that method, we're emitting our custom signal, which broadcasts the current greeting message. When that's done, the index is either incremented or reset to 0 if we're at the end of the array. The script we have on our label, greetinglabel.cs, is a bit simpler. It gets a reference to its timed greeting parent via call to getParent, and we listen to the custom greeting signal all in the _ready method. Since this is a custom signal, we also need to make sure we stop listening to it at some point lest we get errors, so that's done here in _exitTree. Lastly, upon hearing the greeting signal, the label will print the greeting to itself. If anything you just saw was confusing, I strongly recommend you check out my video on signals linked in the description below. Everything is covered in depth there. This timed greeting example hits on all aspects of signals: listening to and responding to built-in signals, declaring and emitting custom signals, and listening to, handling, and ceasing to listen to those custom signals. Now let's swap out the custom signal stuff for a C# event to see what that looks like. First, we'll want to include the system namespace. The system namespace includes some code that will allow us to use shorthand with our events, thus making our code a little bit cleaner. Next, let's comment out this signal declaration. I don't want to delete it because I want you to be able to easily compare and contrast. Next, I'm just going to type the event. And that's it. We start with the public accessor modifier because we obviously want other scripts to have access to this event. Then we use the action keyword, followed by the data type string in opening and closing chevrons. This is how we declare parameters for events. Similarly to other situations where you're using generic types, you'll put each data type for each parameter within these chevrons in order, separated by commas. So if this event, say, took a second parameter that was an integer, we would type this. If it then took a third parameter that was a bool, we would type this. But it doesn't, so we're just going to go back to it being a plain old string. Next, we'll comment out down here where we're emitting the signal, and we're going to replace this with a different line. We're going to type greeting (?) dot invoke, and then we're going to get our greetings array, greetings index. And there we are. So I've made a big deal about events having easier to understand syntax than signals, and then I throw this at you. This is just shorthand though. C# offers a lot of ways to shorthand commonly performed tasks. This is the same as typing this. All we're doing is a null check on greeting, and if it is not null, we call the invoke method and send our current greeting as an argument. An event is a delegate. As explained in the video on signals, delegates are lists of methods that can be called all at once. Delegates are objects, meaning that they can be null and are subject to null reference exceptions. Delegates are considered null if no methods are tied to them. That's why we null check our event. If no methods are tied to the event, we don't even bother calling invoke, so we won't get the null reference exception. Invoke is a method that our events have that we can call, which in turn calls all of the methods tied to our event. Its functionality is the same as the emit signal method you use with custom C# signals. That means all this is saying is, if the greeting event has some methods tied to it, call those methods, and use greetings array, greetings index as the argument. While we're clarifying some shorthand, here's a bonus. This line, just below where we're calling invoke, the line that sets our index to the next correct value, is the same thing as typing this. It's just a fancy way of doing an inline if-else statement called a ternary conditional operator. Huh, the more you know. Back in our TimedGreeting.cs script, we don't have to make any more changes. We've replaced our custom signal with an event, and we're broadcasting that event using a call to invoke after a null check. If we flip on over to the greetinglabel.cs script, you can see that we're not getting any red lines telling us something needs to be refactored due to us having made changes in our other script. That's because everything from the listener's perspective is exactly the same for C# events as it is for custom signals. Subscribing to the event is the same. Unsubscribing from the event is the same. And handling the event is the same. We may want to, change the word signal here in our script just so we have a little bit of clarity, but we don't have to. If you save your script, build your project, and head on back to Godot, you'll see that once you play your project, it's going to be working exactly the same as before. Events that use the action keyword are functionally no different than Godot signals. You listen to them the same way, you stop listening to them the same way, and they do the same thing when they're broadcasted. They can take any number of typed parameters and must be handled by a method that returns void. If, however, your use case is such that you do need to have a return value in your event handlers, you can do that by using the keyword func. This is also an event, but we're using the func keyword as opposed to the action keyword. The int type in the chevrons refers to the return type of the event handler, and not the data type of the event handler's first parameter. This is another event using the func keyword. Here we have 3 data types in the chevrons. In this case, the return type of the event handler would have to be a string, and that method would have to take 2 parameters, the first one being a bool and the second one being an integer. Let's make this a bit clearer. Here we have an action event. That tells us that the methods we write to respond to this event have to have a void return type. There are no chevrons, so we also know there are no parameters. This would be an acceptable event handler for this event. Here is another action event with an integer and a bool in chevrons. Our event handler should return void and take 2 parameters, an integer and a bool, in that order. This would be a good event handler for this event. Now we have a func event, so we know that the first data type in the supplied chevrons, which funcs must always have, is the return type. Since this func only has one data type, we know that's the return type, and there are no parameters. Therefore, this event handler would work great. In this last example, we see 2 data types in the chevrons. If you guess that the bool is the return type of the event handler and there's a single float parameter, you're following along just fine. In the context of events, you won't be using funcs very often. After all, the return type is kind of meaningless to the event itself, as you can have any number of methods returning any number of different values. That said, you may find yourself in a scenario where you have a return method in your class that you want to double as an event handler, and in that case, a func could work. Unfortunately, that's such a niche use case, I can't really think of a good example for one, but hey, you know it exists if you need it. Of course, there are a couple of things to be aware of when using events. First, just like with custom C# signals, you must explicitly unsubscribe from events. That means where you have a plus equals, you need a minus equals. If you don't have a great place in your script to stop listening to an event, you can always use the _exit tree method, just like with custom signals. The reason you need to do this is due to how event delegates work in C#. Remember earlier when I said that delegates are considered null if they have no methods attached to them? Well, if one of those methods is itself made null by having its node removed from the scene tree, the delegate doesn't know that. So when it's invoked, it will try to call a method that doesn't exist, giving you a null reference exception, crashing your game. So, always unsubscribe from C# events and custom signals. Also be aware that both action and func are shortcuts for more complicated syntax. These blocks of code are the same thing. Both the top line and the bottom two lines declare the exact same convo event. Likewise, these two blocks of code are the same. Both are declaring the same exact event, it's just one block is far simpler than the other. It's important to be aware of this in case you research events on your own and find literature radically different than what you're finding here. Just make sure to include the system namespace, and you can use action and func to your heart's content. Those are events, and if my gut is accurate, about a third of you are saying, oh, cool. Another third of you need to go and watch my video on signals still, and the last third still really don't see the point. I'm used to the weird custom signal syntax. Why would I change if it just saves me a few characters? Ah, my friend, to you I say I'll change your mind in the next video on this subject when I show you how to make a static event manager. So make sure to subscribe and press up, up, down, down, left, right on that bell icon so you don't miss that. In the meantime, the best to you and yours. I wish you nothing but joy, and take care of yourself until I see you again. Have a good one.